Welcome to this tutorial on Composites Design. During this video, you will acquire knowledge about the grid approach with import method on CATIA 3D experience. Before starting the manipulations, let's talk about the grid approach with import method. This approach allows the user to import the data required to define plies directly from a spreadsheet. The import design approach is based on the grid design approach. This method is suitable for parts with large numbers of unique plies using common boundaries like wind blades, and slender parts like rods, plates, and shells. The benefits of this approach are time savings for models with a large number of plies, easily manage of large amounts of data in a spreadsheet, and finally, automatically generate planes and boundaries as needed, if not included as a grid reference item. For this method, the user defines the composite ply definition in a spreadsheet based on the part. This method includes 3 different formats for the spreadsheet input: default format with plies group column, default format without plies group column, and long skinny part format with 4 limits and 4 offsets. In the example shown, the spreadsheet captures plies group, sequence, ply, material, orientation, starting and end planes, left and right limits, as well as the associated offsets. The user typically will define the left and right limit inputs as structural reference elements for the grid. This allows the user to ensure the offset direction is correctly associated with the parent limit. For this tutorial, we will use geometry from a wind turbine, especially the pressure side shell. Download the file attached to this tutorial and save it on your computer, in a directory of your choice. The file includes the part geometry and material data. By the end of this tutorial, you will be able to log into 3D Experience and prepare the environment, define the composites parameters, create a grid panel, and import Composites Design data using a spreadsheet. Let's get started. First of all, you have to log into the 3D Experience platform. Open the 3D Experience login window, and put your ID and your password. Then, click on Login. Once you have logged in, click on the compass and filter on the apps to find the Composites Design application. Launch it. Once the application is opened, click on the plus button at the top right and click on Import. Import the file named bladeassembly.3dxml that you put in the directory of your choice, and as soon as the import is complete, press Ctrl+O to open the part, or right-click on the 3D part, and click on Open. The 3dxml file contains several items, but only the composites intros will be used. In the specification tree, right-click on the composites_intros part and open it in a new tab. Ensure that the part is open in the Composites Design application. Before starting Composites Design, it is important to define the parameters of the composite. Composite parameters play an important role in Composites Design. The composite parameters must be defined before proceeding with the Composites Design. The Composite Design commands are only active after the composite parameters have been created. First, let's add materials to composites parameters. In the 3D Experience platform, materials are objects containing the properties of the associated materials. A material consists of a default set of properties and domain definitions that are used to determine the material-related characteristics. You can create new material or import an existing one. In our case, we will import existing materials. Import the composites_material.3dxml file that you put in the directory of your choice. It contains a material catalog including all the materials required for Composites Design. On the Grid Design tab of the action bar, click on the Composites Parameters icon. You can also use the Composites Parameters icon on the Grid Design and the Zones Design tabs. In the Materials tab, click on Add Material. Select from database icon and search for carbon 0.24. In the search window results, select carbon 0.24. Similarly, search for and add Nexus, U174_T800, honeycomb, and balsa materials in the parameters. Now, let's edit the fiber directions. The material directions are the predefined parameters that indicate the fiber direction of the plies. In the Directions tab, select the 0 degrees direction. Click on Edit Direction. In the Direction Properties dialog box, select the green color. Click OK. Similarly, select the colors for other directions as shown in the table. If required, you can add or remove the existing direction. Then, let's define a rosette. A rosette is a graphical representation of fiber orientations. It is computed from a 3D axis system to a given location on a surface. The x direction of the axis system represents 0 degrees fiber orientation and the y direction represents 90 degrees fiber orientation. In the Rosette tab, click on Add Rosettes. In the Rosette Definition dialog box, specify the axis system. The reference axis system for the rosette is already provided under the axis system node in the tree. A rosette has associated transfer types. A rosette transfer type is a method to compute a rosette from an axis system. The following methods are available. First, with a Cartesian method, the rosette is computed using the Cartesian coordinates. Then, with the 0 degrees guided by curve method, the 0 degrees direction is tangent to the selected guide curve at the projected point, where the rosette is to be transferred. Furthermore, with the 90 degrees guided by curve method, the 90 degrees direction is tangent to the selected guide curve at the projected point, where the rosette is to be transferred. Finally, with the external method, the rosette can be developed externally and selected from the list. The Edit button allows you to select the inputs such as curves or parameters to define the rosette if required. In our tutorial, we will use the Cartesian method. So, select the transfer type as Cartesian, specify the constant model size as 20 mm and click OK. Finally, let's create ramp definitions. Ramp definitions define the staggering strategies, which will be available for the composites grid design. Specified ramp supports are associated with each element of the grid panel. Each ramp support group contains grid ramp support curves generated from a structural group of grid panels. The new curves created using this command are used as ply contour supports. First of all, in the Ramp Definition tab, click on Add Ramp Definition. Select Parallel. Parallel is the ramp type. Select the parallel type as multi-parallel. Then, select Parallel Mode as geodesic. Specify the offset value as 0 mm and the step value as 50 mm. Select the automatic checkbox and click OK. Observe that the ramp definition is added to the list. Click OK in the Composites Parameters dialog box. You just finished specifying all the composites parameters. These parameters are listed under the Composites Parameters node in the specification tree. You learned how to add composite material, added the fiber direction, define a rosette and create ramp definition. Now, let's see how to import Composites Design from a spreadsheet. Once the parameters of the composite are defined, the next step is to import the composites data to automatically generate the plies from the information specified in the spreadsheet. On the Grid Design tab of the action bar, click on the Grid Panel icon. In the Panel Definition dialog box, select the surface as Final Introdose. Physically, this surface is the mold used to manufacture the composites part. Specify the draping direction as shown and select Rosette as Rosette.1. The rosette defined in the composite parameters has already been selected. A selection is needed only when multiple rosettes have been defined. You should verify the right rosette is populated. In Reference Elements groups, select the highlighted group. In the Structural Groups field, select the Curves group. Select the curves from the Reference Curves geometrical set in the following sequence. Ensure that you select the curves one by one in the correct sequence. Each curve should exactly correspond to the respective curve's reference element as shown. Change the directions indicated by the blue arrow of the selected elements if required, as shown. To add the ramp definition to this group, select it and click on the Edit button. Select the Same on Both Sides checkbox, and select the 0 to 0 mm, 50 mm ramp strategy. This list comes from the ramp definitions that are created in the parameters of the composite. Click OK. Then, in the Propagate Changes dialog box, select the Yes, including sub-staggering definitions option and click OK. Finally, click OK in the Panel Definitions dialog box. Observe that the Grid panel is created under the Grid definition node with the structural groups and elements. You can double-click the elements in the specification tree to edit the ramp definition if required. Now, let's do the last step of this design method. Import the Composites Design parameters from a spreadsheet. You can import design information from a spreadsheet. This spreadsheet contains names of the sequences, plies, ply groups, materials, orientations, starting and end plane, and left and right limits with possible offset. In addition, you can specify a reference plane and ramp support computation elements. First, on the Grid Design tab, click on the Import Design icon. Select the Format as default format with plies group column. Import of Composites Design requires different input depending on the chosen format. You can view these formats by clicking the View Template option. Then, click on the Browse icon and open the introdos_design_import.xls file. Click on Open File. Observe that the file contains information on the plies attributes and the limiting elements from the ply contour. Select the previously created grid panel. Select the reference plane as plane_0 from the used planes geometrical set. Specify the ramp support step as 10 mm. Select the construction inputs as multi-parallel for the parallel type and geodesic for the parallel mode. Click on Import. Once the design is imported, the results are displayed in the dialog box with the error status. Click OK. Observe that the structural elements and the plies are automatically generated from the inputs specified in the spreadsheet. This is the end of the tutorial. In this video, you learned how to log into 3D Experience and prepare the environment. You learned how to define the parameters of the composite. You saw how to add composite material, how to edit the fiber direction, how to define a rosette, and how to create a ramp definition. And, finally, you learned how to define a grid panel, and how to import Composites Design data using a spreadsheet. Don't hesitate to watch this tutorial again, and reproduce all the steps by pausing the video.